Hello everybody, this is the video tutorial for the S60-109 CAD portion of the primary piston rod. This is where we're going to model this part, and this should be one of the earliest ones you model in the series. One of the most simple models to create. It will involve one sketch containing one entity, and you'll do one extrusion to create this rod-shaped part. So in these assignments, the drawing associated with it in soft copy in PDF format can be found either in the text in the overview assignment or by selecting on it in the procedure. It's the same PDF. And you should have already found this page because the video, when posted, will be listed on the assignment. So to do this, you have to be logged into the lab, and you need to have SolidWorks running. And either a hard copy of the drawing, or you can display the PDF and switch back and forth. For simple parts, that's fine. Any of these drawings that have a size of A is fit on a standard 8.5 by 11 sheet of paper and can be printed. A good portion of the drawings for this class are actually B size, so that's tabloid size in printing world. It's 11 by 17 paper. You may have to get access to a larger printer if you need to print it. And then we have SolidWorks running. So we are going to be creating a part file. So we want to select part. And we're going to go ahead and accept the default settings, which should be inch, pounds, and seconds, and ANSI standards. We're going to select OK. Now, the pane on the right is a help pane. It's intended to help you out with new commands. You may want to leave it running, but I'm going to minimize it so that I have more room to show what we're doing here. And again, we have our feature tree on the left with a history of how you're building your part. And we're going to start off, and the very first thing we're going to do is we're going to save our file. So save it initially so we establish the name. Save as, and again, you're going to want to navigate to your H drive or a local drive, like a zip USB drive, to save your part. Don't save it in the lab local PC. Okay, so to do so, I'm going to go up, and yours will be an H drive, but I don't have a demonstration of that, so I'm going to. So file management, however you like, as long as you don't move the files around. I'm going to make a folder for this project, and I'm going to call it the Sterling 60. That's what the S60 stands for. We're developing parts to build a Sterling engine, a simple Sterling engine. And within that, we're going to name it the part number, which is S60-109 underscore, and we want to match the revision on the drawing. So let's go back to the drawing, and this is revision 0. So we're going to put the letter R and 0. Now if we had to go and update this part, the drawing might have a revision 1, 2, 3, or letters, depending on where it is in the design cycle. Many companies use numbers for prototype, and when they have solidified their design after building prototypes, they'll switch to letters, which designate its production revision. So you might have a revision 5, and then the next revision is revision A, and there's been no change between the two other than the revision. Okay, so, and then as the instructions say, I'm going to put T underscore and my name, but you're going to want to put your name. Don't follow the tutorial and just type Todd Frazee on there. I actually prefer its caps, but I'm not going to grade you on that. That's just a drafting technical convention. So anyway, but you will be graded on whether you have all these elements. That's included in the rubric. So make sure this is correct, because otherwise when you go to make the part, you may be making the incorrect part or the incorrect version of the part. Okay, so we saved it. The next step we're going to do is by default the planes are invisible. For new users, I think it's better to have them visible, and as you get comfortable you can leave them hidden. So first thing we're going to do is we're going to go to the front view. We're going to make it visible, the top plane make it visible, and the right plane we're going to make it visible. So these are our three planes that define the different linear axes of X, Y, and Z. And it lines up with our axis trihedron, and some software calls these gnomes. Okay, so you can click on the axis if you want to look straight in on it, that particular axis. And it's best practice to have your most detailed view in the front plane. If you're trying to set it up for specifically machining, you want the part orientated so that the Z-axis is in line with the spindle of that particular machine. From a design standpoint, it doesn't really matter because we can change that when we get into the CAM package. So for this particular part, we're actually, it's just a rod, and in the front view you'd want to see the biggest portion of it. So we're actually going to draw it in orientation so the front plane is looking at the side of the part. So we're going to go through, and first you start off in sketch mode, so which is the sketch workspace. Select sketch, and then you select the sketch icon, and that enters the workspace itself. It says you're going to create a sketch, and there's going to be things contained within that sketch, like an envelope. Now, for more advanced geometry, you have to have multiple sketches to create the advanced geometry. So we need one sketch, and we're actually going to select the right plane. So we're going to select the right hand plane, and it'll zoom to the right hand plane. And our feature, a major feature on this, our drawing, is it's a diameter of 0.094. Now that's actually a fractional size, and it goes out another decimal point. The tolerance dictates that we only have 3 place decimals, but we're actually going to go beyond that so that we get the correct size. So the nominal size of this rod is actually 3/32. Okay, so we want to actually model it at 3/32. So let's go back to SolidWorks, and we're going to draw a circle, and we're going to pick the origin, and you want to have the coincident icon, which is showing up in yellow, and you're going to select there, and that'll anchor our circle at 0, 0, 0 on the right plane, right side plane. And then click an arbitrary place, and you should have a circle that's blue. That means, again, that means it's not fully constrained yet. It's constrained that the center of the circle is on origin, so that's good. Our second constraint we need is the diameter. So we're going to go to Smart Dimensions. We're going to highlight that diameter. We're going to click where we want to place our dimension. Try to place your dimensions when you have multiple ones so that they're not on top of each other, so that it's easier to select them. So the default size I happen to draw was 1.5 inches, and that's way bigger than what we're making. So again, that's 3/32, and you can actually put the math right in SolidWorks. So I'm going to put 3, division symbol, 30 seconds, and press enter, and it actually calculates out. If I double click on this, you can see it calculates out to 5 decimal points. Okay. Now the display is rounding up because it's only showing 2. So let's go ahead and go over to the sidebar, and you have all these options on what to do to this dimension. Now this doesn't necessarily affect the drawing level of things, but you can automate your drawing, which is not part of this class, but if you lay out your dimensions in the model, you can extract those dimensions and not have to edit them if you set up this properly. So this is how we're going to approach it. We want to know as a machinist that this is actually 93.75, even though the drawing is going to give us a tolerance to round that off to 9.094. Okay, so it has the true dimension there in the box that I have highlighted with my cursor. And then we want our tolerance to match what we would put on the drawing. So it's going to put 094. If I were to change this to 5 places, it's going to give you the full number. We have to be careful of that because that can denote the tolerance at which you make the part at. Okay, and if you notice that our circle is turned black, and if we expand our feature tree on the left, we've got our sketch here, and there isn't a negative symbol next to it, so it should be fully constrained. So once you have the fully constrained sketch of a circle with a relationship with the center, coincident with origin, and a dimension of 3/32, you're going to select Exit Sketch. And over on the left, you should have that sketch that you created. If your sketch is not fully constrained, it's going to have a little bracket with a negative symbol in there, and you need to go back in and fix that. That's an important part of your grade. It's about 25% of the grade of every single model you're going to do in this class. So I'm adamant you need to have all your sketches constrained. Otherwise, you're doing sloppy freeform modeling that will cause problems for you later. All right, so we're going to take this circle and we're going to go to the Features command, and we're going to make our base feature. So usually the base feature is extruded, revolved, swept, lofted, one of those. We're going to use the most basic. In the next lecture, we're going to be going over several of these so that you know how they function. But the base extrude takes this, and it's as if you extruded material through it. You can think of perhaps like your toothpaste tube. You've got a circular hole in the toothpaste tube, and when you squeeze on that toothpaste, you're extruding out a cylinder shape out of that toothpaste. So we're going to select Extrude and Base, and it's asking you what do you want to extrude, and we're going to extrude our circle. And now it's going to ask you how far. So let's go to our drawing and see how far we need to go. So our dimension is 1 inch, 340 thousandths, plus or minus 20. So that's a symmetric tolerance. So we don't need, because it's symmetric, we don't have to worry about the tolerance. And we're going to type in 1.34. So let's go back to SolidWorks, and we're going to type in 1.34. We're going to select the green check mark, tells it SolidWorks you're done with that cycle, and it should extrude the rod to the length of 1.34. Okay, and we're going to hit OK, and we get this gray rod. And it's just the generic rendering. You have now made your first solid model using the extrude command, and it moves the planes to be the size of the part. And now you've done that, you can go back and select on them and hide those planes. It's up to you. When you start later on, you'll see when we start doing assemblies, the planes can become a distraction. Now I'm going to show you one more neat thing here. It's not critical to CAD CAM, but it does define what the material is. It is important to design and when you're doing the finite analysis engineering. So what we can do is we can go to Material and edit the material. So by right-clicking on Material here, we can edit the properties, and they have loaded in the properties of several different, lots of materials, different alloys. And so this particular component, if we go back to our drawing, is made out of 360 brass, S60-802, which means half hard, and to the standard of ASTM B16. Now, I'm sure if you dig into the specifications, you could create material that's specifically that, and you'll get the correct mechanical properties. But for the purpose of this class, you'll get the mass properties and the close by just calling out brass. Okay, so let's go back to SolidWorks, and we're going to go to copper alloys, which brass is a copper alloy. Okay, we're going to select brass, and it has all the specific gravity and different properties associated with that. Yield strength, density. And it also is going to change the appearance of the model. So I just applied the material there. It's brass. And what that allows you to do is use this Evaluate tab. And you can use mass properties. And so this particular part is center of mass is at 0.67, which is showing the center of gravity. Our settings for mass is too big to show the weight of this, but typically the weight would show up there. So we needed to change with the configurations to use more decimal points. And we get the weight of the part. So it's 0.0028 pounds at 0.037 pounds per square inch. So at the scale of this part, it's smaller than your typical part. But if you were trying to calculate where the center of gravity or the mass of a product, you can use this for your tools. Also in the Evaluate, you can use the Measure tool, which allows you to pick up on edges and features and measure things like it gives me the nominal diameter and length. Good job. You've finished your first model. Make sure you save off your part and upload it in Canvas on time for full credit. And that would be here. And in your view, you'd have start assignment, and then at the end you could upload the part as a SLD PRT file. All right, thanks a lot, and I'll catch you on the next video.